We have 4 weeks of the course on processes. So we've done 2 weeks. This is the 3rd week on processes. We have another week on processes. It's such a key topic. I was talking to the MBA director at Ohio University, and they do a short operations course in summer, and they spend like 2/3 of the course on processes. So it's a really key topic. Today we're going to take a high-level view. We're not going to go into details, capacity, cycle time anymore. Take a high-level view of processes and look at them from like a general manager's perspective from a really high level. So what we're going to do is, just so everybody has an idea of what we're talking about, I'm going to show you a video which is going to illustrate some different types of processes. So when I mention job shop, this and that, you can at least visualize what's kind of going on. Okay, so
Every day, consumers around the world purchase a variety of products. These goods range from standardized commodities such as gasoline and motor oil, all the way to items which are made to order, like eyeglasses and many services. In order to create a high-quality product while being efficient and cost-effective, any company must select a manufacturing process that best matches the product. As a rule, the product being created determines the appropriate process. Process selection is based on 2 considerations. The first consideration is variety, or how much the product changes from customer to customer. Gasoline is a very standardized product. Although there may be a small variety between different blends, within each blend the product remains consistent. Eyeglasses, on the other hand, must be custom-made for every individual user. The second consideration is volume of demand. There is a large and constant need for gasoline, so operators refine and distribute it as quickly as possible. Glasses are custom-made to order, matching a prescription, and cannot be made in advance. A third consideration, the flexibility of the equipment used to create the product, is determined by the product being created and is often determined by the first 2. These 2 main factors, variety and volume, may be seen as the vertical and horizontal axes of a graph. The result is called the product process matrix. The most efficient production or manufacturing processes are found along the diagonal points on the graph. When a very standardized product is needed in very large volumes, a continuous process is the best manufacturing choice. This process uses highly specialized equipment with very little flexibility and is almost completely automated. Gasoline manufacturer BP refines crude oil into premium fuel in refineries across the globe. There is a constant need for its product, so production is continuous. In fact, its refineries in the United States process 1.5 million barrels of crude oil every day. These plants operate 24 hours a day, 365 days a year, in order to maintain cost effectiveness and match output to demand from consumers. Because of the large capacity of the operation, it is very expensive to shut down such a plant. Stopping production for just a few days can undermine a plant's profitability for an entire year. BP's facilities refine crude oil into a number of consumer products. Each barrel of oil contains 42 U.S. gallons, which is refined into 19.4 gallons of gasoline, 9.7 gallons of heating oil and diesel fuel, 4.3 gallons of jet fuel, and a host of other products. The first step in refining is separating the crude oil into these various components. Refineries have the flexibility to manufacture both gasoline and heating oil, but within the plant, each piece of equipment performs a very specific function. The process is automated, so operators spend much of their time monitoring and adjusting processes from a centralized control room. Chemical engineers determine the mix of products added during the conversion and treatment stages of the process. Others monitor such elements as the water used in the refinery to ensure that it's safe to return to the environment. The workers at the plant represent a wide range of specialized skills without much overlap. For a global petroleum producer like BP, continuous production is the most effective process choice. In many cases, though, consumers demand some degree of customization. In order to deliver a high volume of output and still offer some variety, manufacturers turn to a repetitive process called an assembly line. This is also referred to as mass production. Most consumer goods are mass-produced. Honda of America uses a repetitive process in their operating plant in Marysville, Ohio. At this plant, Honda produces a large number of only a few different models of their popular Civic line of cars. In fact, this plant alone produces an average of 20,000 cars every month, nearly 250,000 for each model year. The production process utilizes a connected workflow in which the product moves along a conveyor system past a series of workstations. At each station, parts are brought to the line to be added or assembled until the product is finished. In traditional assembly lines, workers complete the same task over and over. At Honda, workers are trained in a variety of tasks. They rotate workstations regularly to avoid fatigue and to maintain quality. Because each station is designed for a specific task, there is little need for flexible equipment. Workers interact with tools more than in a continuous process, but much of the work, such as welding, is performed through automation. Still, there's enough flexibility at each workstation to offer a variety of options on the model being produced. In repetitive processing, variety is created by combining individual modules. Engines, for example, are created separately from the main assembly line, allowing engines with different specifications to go into the same model. Body color and interior features and plug-in items, such as stereos and accessories, are examples of other modules that create variety within the steady, repetitive flow. While this process is so structured that each line produces only one type of product, the line that produces the Civic, for example, cannot build an Acura, Honda is seeking to change that. At its Ohio plant, for example, workers are trained on the next season's model of cars while they are still building the current model. Industrial engineers, meanwhile, are looking for ways to redesign the assembly line, building in so much flexibility that it could produce any model the company makes. In Aurora, Illinois, Caterpillar is already doing what Honda hopes to accomplish. This plant produces 24 different models of wheel loaders, compactors, excavators, and agricultural tractors, all in the same facility. Caterpillar produces 4 families of construction and agricultural equipment, but all in relatively low volumes. Because the volume of products they manufacture is lower than Honda's, and the variety of machine is greater, Caterpillar makes use of batch processing. This process creates products in small lots, or batches, in much smaller volume than Honda. Unlike repetitive processing, which depends on a connected workflow, batch processing involves a disconnected production line. Processing is intermittent, with workers coming to the machine rather than the product coming to them. A variety of products produced at relatively low volume with flexible equipment characterize a batch manufacturing process. Sometimes, products are created in batches as small as one. When a highly specialized product is needed in a very low volume based on an individual customer order, the process which matches the product is often referred to as a job shop. Eyeglasses are made using such a job shop process. Each pair is made to suit a specific customer's vision and head shape, so each pair must be created individually. At AED Vision, optician Jim Bracken has been making glasses for more than 20 years. He stocks lens blanks, which have already been ground to a specific prescription strength. After choosing the proper strength lens, Jim uses a bevel edger to custom cut the lens to the specific frames the customer has chosen. He then uses a hand edger to grind out any imperfections. The lenses are fitted by hand to the frames.
Hi, how are you?
Good, how are you?
Yeah, I got a beautiful pair of glasses for you.
All right, I can't wait to see them.
Finally, he fine-tunes the fit of the frame to the size and shape of the client's head. Although many of these same steps go into the creation of every set of glasses, fitting the lens to the frame and the frame to the customer is unique every time. Outside of the bevel edger, none of the equipment Jim uses is specific to his industry. Standard table salt in a pan on a hot plate serves as a heat source to soften plastic frames for bending. A nearby pan of water cools the frames. Standard flexible tools, such as a screwdriver and pliers, are used to fit metal frames. This is typical of many job shops, where a small set of general-purpose tools are used in a variety of ways. Because every product is custom-made, the equipment must be flexible enough to change with each new task. And since volume is small, the process can be geared to providing an exact, custom product. Highly skilled workers using general-purpose tools to produce a small volume of very specialized products is typical of the job shop production processes. The product process matrix illustrates the general rules of manufacturing or production processes. Finding and using the appropriate process is necessary to ensure quality and keep costs low enough to match the market demand and volume. It is unusual, however, that a product will fit so neatly into one process or another, and many products depend on several processes for their creation. These hybrid processes are becoming more and more common. The steel which goes into Honda's cars and Caterpillar's heavy equipment, for example, is created through a continuous process. If you order specialized stereo equipment for your car, it may be produced through batch processing. Although the eyeglasses created at AED are built in a job shop, the frames may have been created on an assembly line and the glass blank for the lenses through a continuous process. For many manufacturers, the goal is to create high-quality products with the efficiency of a continuous process while building in as much flexibility as possible in order to allow for more and more customization. At the same time, small volume producers search for methods to produce greater volume of specialized products at lower prices. In order to achieve this mass customization, manufacturers must understand the dynamic of the product process matrix.
Okay, let's get back to our lecture. So today we're going to consider high-level process choices about whether the company should design themselves after an assembly line or batch processing, things like that. Yeah. So let's go over these kind of 4 archetypes and see what are their characteristics. The video kind of talked about them as well, so hopefully you'll remember some of this stuff from the video. Okay. One way to look at a job process is, or a job shop, is that you'll find there are different kind of areas or departments in the job shop. So where you see the A's, the area where the A operation happens all have similar equipment and similar things happen in this department. Then you have other departments, and different products will take different paths through the facility. Not every product will need every department to work on them. So some will go to A, B, and then E. Some will go different paths. So if you look at the path which the product takes, you'll see what's sometimes called jumbled flow through. It's not going to be linear. It's not going to go straight from one end to the other end. It's going to take a different path. One example that most of us might have seen of a job shop or experienced is a hospital. So when people walk into a hospital, different people take different paths through the different departments. Somebody needs an x-ray, somebody doesn't need an x-ray, right? So depending on why you are there, what service you need, so you can take a different path through the hospital. Right? Also, you'll see hospitals organized as departments by specialty. So radiology department, right? You may have ENT, I don't know, for something for bones. I don't know all the medical terms, but you have different departments by different specialty, and different customers take a different path through those specialties. These things that we talk about are often relative, right? So job shops compared to the other types will tend to have more highly skilled workforce. So hospitals have doctors, nurses, highly skilled. If you're doing some sort of machining, why do they need a highly skilled workforce? Because they make so many different products or handle so many different customers that the equipment and tools they use are often kind of general purpose, and they use them in a different ways for different orders or different products or different customers, right? And so if you're making many different types of products, you will need to have a higher level of skill to be able to use the same equipment across all these different products. Okay. So what are some examples of job shops? We talk about hospitals in the service industry. In manufacturing, sometimes you're going to be making parts in small volumes, but a large number of parts, and then you could also have a job shop in that case. Yeah. When we do say equipment is more general purpose, I want to make sure we are all on the same page, because that doesn't mean that equipment can do 2,000 different things. An X-ray machine just does X-rays. But why is it more general purpose? Because it can handle many different customers. You can get an X-ray done of your leg, an X-ray done of, so whenever you have a huge subset of customers to a hospital can use that X-ray machine or go through that X-ray equipment. So it's general purpose, meaning it applies across different products and different customers, not that it can make your coffee and iron your clothes and do something else, okay? Same thing for manufacturing. If you have a cutting machine, it may be doing cuts for many different products, but it's still a cutting machine. It can only do cutting. It cannot do anything else, right? So that's what we mean by general purpose. When we go to continuous flow, we'll see equipment become specialized for a particular product or a particular type of customer, okay? So equipment still does kind of one type of thing, but it can be applied across products or customers or not, is what we mean by general purpose, okay? Why do we have job shop type of setups? That is when we need specialization. So we need, workers to get highly skilled at certain tasks, and then we say, okay, all this task about all products which require that task, this department will do them, because we need a high level of skill for that. Okay? Job shops are very flexible because workers are highly skilled. Equipment can be applied to many different customers and products. You can handle a large variety and customization. Okay? So for example, if you were building, let's take 2 furniture manufacturers. One furniture manufacturer is supplying chairs for IKEA, maybe some particular model. Another furniture manufacturer does custom furniture. You walk in, you look at their catalog, you say, I want a chair of this color, this height, with this sort of embellishment on it, and then they make it based on your custom order. Okay? So do you think this custom furniture manufacturer is going to be more like a job shop, or the person who makes chairs for IKEA is going to be more like a job shop? Why?
Because it makes these specific products.
Right. Right. So whenever you have a more variety and less volume per product, you're going to be more like a job shop. Whenever you have less variety and lots of volumes per product, you're going to be more like something else, like assembly line or something like that, right? Because then you can invest in equipment specific to one product, because you're going to have lots of volumes, so it'll pay back for itself. But if you're making something different every day, then you want to get specialized process and equipment for just one product. You're only going to make a few quantity of that, right? Okay. In terms of costs, in a job shop, you are frequently changing over. So you made one order for one customer, then you maybe have to retool equipment, reset machines, or clean up before you make the next order. So there's often time spent when changing from one order to the other order. Okay. These require a skilled workforce, so you talked about that. Often leads to unbalanced work, right? Because if you get a few orders of one type, one day the X-ray department might be overloaded, the other day it might not be overloaded. So you're not going to get equal volumes going through all departments every single day. So their volumes will go up and down based on the orders they are getting. Okay? And you can't predict what order you're going to get, because every customer, because there's so much variety you're offering, or you're offering customization, every customer will pick something different, so it's kind of hard to predict, right? Okay, so if you're managing a job shop, you kind of have to be aware that you might see, low utilization as compared to other setups. You might see unbalanced workloads. You might have to pay your workers more because they have high skills, things like that. Okay? So what are the advantages? Well, you can have a lot of flexibility and customization, flexibility in product variety and design, same thing about customization. Also, flexibility could be in terms of, because you're not pushing a high volumes, right? You're going to have some WIP because of unbalanced workflow, but because you're not producing each order in a high volume, you might be able to get to new orders quickly. So if somebody comes in and says, I want this order, the orders in your existing pipeline are for small quantities usually, so you can then kind of push them through sometimes faster than if you had large batches. Okay. So the second type you're going to go is into batch processing, which is, you can think of, you just take a job shop, you reduce the variety or customization options, and you increase the volume per order or per product. And then you start moving towards batch processing. So because you have higher volumes, less variety, you can start to specialize some of the equipment. You can start to standardize some of the work and have less skilled workforce, things like that. Okay? There are some scenarios where it's not as much about options and variety and customization as it is that naturally that process lends itself to being done in batches. So sometimes you have processing to do where your cost does not increase linearly with volume. So if you produce more volume, double the volume, your cost does not double. So then you have an incentive to produce in batches or large batches. So an example would be this classroom. If we had 10 more students here, the cost to the university would not increase. They'll fit in the same room, right? And you still have just one instructor, right? So instead of having very small classes, universities like to have some minimum batch size for classes, because the cost does not increase linearly with each additional student. Right. Same thing if you go to a theme park and you want to take a ride, and if you can put 50 people on the ride, right, then the cost to run the ride once is approximately, they might be with load, the fuel cost might change a little bit, but approximately the cost will not double if you have the ride full versus half full. Right? And so then you want to do batching. Benihana, same idea. The cost you pay to the chef, which is the most expensive resource, is the same whether the chef cooks for one person or 8 people. So you do the batching in the bar, and then you do batch processing in Benihana versus some other restaurant. Okay. So it's just like a variation of a job shop, but you have lower variety, higher volumes. This is very common in the chemical industry because you have these large reaction tanks where you mix different chemicals, and then you have to clean up the tank before you can make something else. right? So what happens is when you change from one chemical to another chemical, there's a lot of cost and time involved to clean everything to be ready and sterilize it for the next chemical. So whenever you have a high changeover cost, what does it take to change from product A to product B? When that cost and time are large, then you want to make product A for a long time before you switch, because if you keep switching, you're going to waste a lot of time and cost. So you want to minimize the switches that happen. So if it's a big volume of A, then you switch, big volume of B, then you switch. So again, that would be batch processing, right? Okay. Competitively, when do we call it a job shop versus batch processing? Job shop tend to have higher variety and higher customization, higher worker skill. Batch processing will tend to have higher cost in terms of setup cost. Why? Because if the cost was really high here, they would tend to go towards larger batch sizes and become batch processing. So this can kind of sometimes drive between the two. Job shop will still have some batching, but often their batch sizes will be smaller because each order is customized. They can't have bigger batches. And the total volume per product will also tend to be higher for batch processing than a job shop. Okay. Let's go to the third one, which is in the video they called assembly line or mass production. The more generic term is a line process. And why is it called a line process? Because as opposed to this, where you can have many different paths possible, in a line process the product flow is very sequential, so it kind of goes in one line. Okay. Now because of physical constraints, you might have the line go up and down, but it's still just one path. So by a line, it doesn't mean it has to be line horizontally. It could kind of take a different path up and down to fit everything in the facility, but every unit you make is going to take the same path through the facility. So you don't have different product going different paths, right? Okay, so in a line process, when do we use it? What are the advantages? It's used when your volumes are high because there's a cost to setting the line up, because you have to have equipment in certain slots, you have to have maybe conveyors or some sort of carts to move product along. So all that setup has some fixed costs. You want to do that fixed cost when you have large volumes for a product you're going to make on the line. Okay. Lines can often make more than one product, but they'll be very similar products. So let's say you have 3 cell phone models, and the only thing that's different is the screen, maybe quality, and the battery. So you pick the screen that is for that model, but you're still essentially making the same product, right? So variations of a product you can still do on a line. Okay. Often in line processing, we try to standardize the tasks. So if you're at a particular workstation on the line, you're going to do the same thing the whole day. Why do we do that? Well, we don't need a lot of high-skilled labor then. That can reduce our labor costs. And because we're going to make a product in a large volume, and usually products tend to have longer life cycles as well, then we can invest money and time into making standardized tasks and specialized equipment, because you have to kind of map out exactly what needs to be done, time it, kind of standardize the operations, and then just do that over and over again. So the whole thing to set it up is costly. You want to set it up if you have high volumes. Okay? Sometimes line processes are one-piece flow, so you just have a whip of one between stages. This is very common when you have the conveyor system, like you saw in the video, car kind of moving along. So you don't install the seat on 10 cars, then move 10 cars over. Just do one car at a time, and it keeps moving forward, right? So you have one-piece flow. Often when you have machine paced lines, which are paced by a conveyor or some machine, you'll have kind of like one-piece flow. But sometimes you'll have worker paced line, which is like an assembly line, but you don't have a conveyor moving. A worker does their thing, they loads up stuff into a cart or a box, they move that to the next station, then they go do the next box or the next cart worth of goods. So you have some small batching, but it's much smaller than batch processing or a job shop. Okay. Why would you go for worker paced versus machine paced, or when would you go? Well, when can you do machine paced? When can you do when would you do worker paced? Right, so machine paced has a much higher fixed cost to set up. You have to set up all the conveyor system. Plus, in the machine paced, workers have to work at the same pace. Now, if you're doing something very simple, like tightening some screws, installing something, that's fine. You can kind of see how long it takes and if it takes the same thing every day, right? The worker pace you go towards when volumes are low because you're not setting up any equipment. You just have some cheap carts. You put product in them, move the cart over, right? And their workers have a little bit more flexibility. They can have a little bit more variety. Why? Because, you know, there's nothing moving under them. They don't have to finish in a particular time. They can have more variability in their processing times according to the product variety and things like that. Okay, so we already talked about that our equipment is going to tend to be special for the products we are making, which is why we tend to be able to make products faster at lower variable costs. So this is very good when you want to have, when you have low margin industries where you want to make a product with low cost. Initial costs may be high, but then variable costs are low. Okay. In many industries, the final assembly is a line process. So at the end, you have to put some things together to make the final product. Assembly operations are often done in a line process. Okay. In some industries, the components may be made in line process as well. In others, the components may be made in batch processing, and then you might just do the final assembly as a line process. Actually, when Ford started with Model T and they did a line process to assemble the Model T, the parts were still being made by batch processes. So they have this assembly line here, but all the parts were coming in big batches from suppliers or other parts of the factory where they were making the parts. And really the efficiency really was just in the final assembly, right? When the Japanese saw that, they said, well, this is not good enough. If the assembly line is more efficient, right, then why don't we make the components in assembly lines as well? So in Toyota, for example, you would have the car seat manufacturer right next door. They would make just enough car seats as the final assembly line needs, and in some cases you'd have a conveyor system taking the car seats out of the car seat manufacturing straight to the assembly line assembling the cars. So you have assembly lines feeding into other assembly lines feeding into the final assembly line, and so you don't have any batch processing. The whole thing is like, you know, just very little work in process inventory start to finish in the whole kind of line. So we'll talk about it more next week, but that's sometimes called the just-in-time production system or the Toyota production system, which basically means go back up the supply chain and eliminate batch processing and kind of get towards these more leaner type of production, right? Obviously, to do that, your supplier has to be assured of higher volumes, because if the supplier thinks you might go away the next day, why would it specialize its equipment for the car seats you need or the component you need and do a line processing? Right? So to be able to convince your supplier to also go to line processing, there needs to be more stuff put in place, which we study a lot more detail in the supply chain course, but essentially your supplier needs to know that you're going to give them enough volumes and you're in it for the long term, and then they will do the investment to be line kind of as well. Okay, line processes, although it's kind of, you know, if you look at videos or you think about it, you see it's kind of like working like clockwork. You set up the line, product moves along, things happen, standardized workflow. So it looks like a machine almost with humans as part of that machine, right? So sometimes people can get the idea that line process is just like a machine. You set it up and then you're done. You can relax. There is actually active management involved in line processes. Even if you have an assembly line, you'll still need some sort of managerial staff, supervisors, foremans, or managers to kind of look after the line. Okay? Why is that? Why would you need active management in a line process? What do you guys think? What could go wrong where you need to have a manager around to do something? Right, so the line could stop and then you have to kind of restart it or do something. So something could happen you don't expect. Equipment breakdown happens, or you know, you run out of parts, and then you have to figure out what to do. Do you stop this line? Do you move workforce? So unexpected events could happen. Very good. Other examples of unexpected events or things that can happen? Right, so as you get to lower skilled workforce, probably their wages are also falling. They're not paying as high as a doctor, nurse, job shop type of worker. So the more you go to low-skilled, low-wage workforce, the more you see issues of absenteeism, because you know they could get minimum wage job anywhere else. Right? Why would they show up? So you may have, you know, a line designed for 12 workers, and then one day you go and only 10 show up. So now you have to reassign the work across 10 stations, or quickly train somebody else to come fill in the spot, or you might have some floater workers, things like that. So there's always something going on where you have to readjust the line. So the line almost is never constant over a long period of time. Then you could have workers get tired at the end of the day, so maybe they'll start working slower. If it's a machine-paced line, somebody has to kind of adjust the line or motivate the workers. Then you could have some worker left, a new worker came in, their training is not as good, or they don't have enough experience, they have a higher defect rate, so maybe you want to move them to an area where they can't make as many errors, things like that. So there is active management still involved, because you will have variability being brought in by the workforce. Your equipment may not bring in a lot of variability, but the workforce will bring variability into the process that you have to manage. So the last one, which tends to have the lowest variable cost per unit, is called a continuous flow process. The reason it's called continuous flow is that once the production kind of starts, things move through the whole process without stopping. Okay? Think about oil refineries. You pump in crude oil in one side, they do the whole process, and everything kind of keeps flowing through, or things happen automatically. In a way, it's highly automated usually. Okay? The main difference you'll notice is that in a continuous flow process, workers don't work on the product usually. Okay? Machines work on the product, workers just make sure the machines are maintained and running properly. So they're usually highly automated processes, which means extremely high fixed cost to set up, which means you would only do them if you are assured a very high volume for a very long time. So things like fuel, cement, some basic chemicals like sulfuric acid used in so many industries, things like that. You would do continuous flow process because you're assured this item is going to be used for a long time in large volumes. Oops. Okay. High fixed costs, low variable costs, high volumes, right? So you need to maintain high utilization to break even. If these sorts of plants kind of stop for a week, 2 weeks, they could lose the profit for the whole year, because usually for these types of things, the margins on the products are very low. Why? Because fuel is fuel, gas is gas, sulfuric acid is sulfuric acid. There's no differentiation. There's not much brand name in a way. So people will just buy the lowest cost if there's competition, right? So usually there's low margin industries. You have to have the volumes and utilization to get to be profitable. Okay. Very fast assembly lines can often be continuous flow. So if you see videos of how newspapers are printed, or paper is made, or diapers are made, you'll see these automated assembly lines running at like 70 miles an hour type of thing, products just flowing past, and they are continuous flow. Like, it's kind of like they started as an assembly line, but they brought so much automation in that the assembly line speed up so fast that now workers don't touch the product anymore. It just kind of flows through, and it's become continuous flow from an assembly line. Okay, so let's see an example of a line process, and then I'm going to ask you 2 questions. Is a line process suitable for what is being done? Okay, and then how can we improve the process? Okay. So it's a short video, so I might have to play it a second time so you guys can actually concentrate on the process. Okay, so this is an ad. This is not the video. I have to skip the ad.
Department.
Yes, ma'am.
Now, the candy will pass by on this conveyor belt and continue into the next room where the girls will pack it. Now, your job is to take each piece of candy and wrap it in one of these papers and then put it back on the belt. You understand?
Yes, sir. Yes, ma'am.
Let her roll! Let her roll! Well, wait here. Somebody's asleep at the switch.
What are you doing up here? I thought you were downstairs boxing chocolates. Oh, they kicked me out of there fast. Why? I kept pinching them to see what kind they were. This is the 4th department I've been in. Oh, I didn't do so well either.
All right, girls. Now, this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired.
Yes, ma'am.
Let her roll!
my list, okay? Listen, Ethel, I think this... I think we're fighting a losing game. Here she comes.
Fine, you're doing splendidly. Speed it up!
Yeah, so should candy wrapping be a line process? No. Shaking head is a no or a yes. Wrapping chocolates, so they're in the packaging department of a chocolate factory. So should that high level question, should that be set up as a line process? Because it was a line process, right? Should that be set up as a line process? Right. No. Yeah. So the speed is under our control, so we can adjust it up and down, right? So you could have a slower running line versus a faster running line, but still, should it be line? So how would you answer that? You would look at what? Can the task be standardized? Are the volumes high? Things like that. So what do you guys think? Volumes are going to be high because you're probably at least in this department making candy of similar size. So when you have different type of candy, the wrapping part is kind of like the same for across those products. So you might say, okay, total volume might be high. What about the task? Is it different for different products? Can it be standardized? It could be standardized, right? What do you guys think in the video? Was it standardized? Was every output looking the same as other output? Oh, really? Okay. So every candy is getting wrapped exactly the same. So if you were a kid, you bought 10 candies, they would be exactly similarly wrapped. Yeah, if you take that sort of a view, there's a wrapper. Yes, they're going to have a wrapper. But do you think they're wrapped the exact same way? No, right? Even the two workers are wrapping differently, and each candy was a little bit differently wrapped. So the way the work was explained to them, it was not really standardized, because when we talk about standardization, it's like, you move your arm 10 inches here, you pick up this thing, you do this fold, you do this fold. It's a very minute level of detail. I don't know if they still have those books or it's online, but you could buy a book, like a thick book, which would give you standard times for different movements and operations, and then you could break up your work into those individual movements and operations and figure out what time it should take. So they would do experiments. Okay, what time does it take to pick up a screw from 12 inches away? What time does it take to pick up a screwdriver? What time does it take to screw in a screw? Things like that. So you find a whole book of those times published, and you would break up your task into these minute things, and then say, okay, this is how long it should take. So they've not done that yet. The way they wrap is totally up to the worker right now, right? And then obviously the issue with the speed of the line, it's too fast, it's not worker paced, maybe they should do worker paced, things like that, right? Great. So let's say they slow down the speed. The end was just to be funny, they sped it up too much. So let's say it's like the starting speed. So slow down the speed is kind of reasonable speed now. Anything else you would do other than slow the line down? Is the speed the only issue, or there's other things you would do? Right. Yeah. The other thing that they've kind of done is they've put two workers to increase capacity, but the workers are one after the other. Usually in a line, every new worker is a different step. So either you can put them across each other or make two lines, because right now, it's kind of hard for them to divide the work between themselves. And they're also working on they're moving the chocolate to this person, so they're both working in parallel, which they shouldn't have to do. So the work should happen in parallel naturally, right? So you could rearrange the line, have two lines, or have worker pace line where they get a whole box of unwrapped chocolate. They're both next to the box on different sides. They can both reach in, pick out at the same time. So they're not, interfering with each other's work, right? So you could actually do a few things to improve it other than just the speed. And so when we talk about a line process, we want to get to a high level of standardization. Okay, so let's kind of summarize everything we kind of talked about. We have process-focused processing, where each worker is focused on a particular task. You're an X-ray person, you're an ultrasound person, you're an ENT doctor, things like that, or you run, cutting machines, you run machines with smooth stuff, things like that, right? So work is divided based on the nature of the task. Here, work is divided based on the product, because different products go to different lines, right? You have a line that continuous flow for a few types of products only, right? Volumes are high that way, variety is high this way, customization is high this way, right? So straightforward, just summarizing kind of what we did. Okay, so what people noticed working in manufacturing, and then they kind of tested this, so there have been empirical studies testing this. What they found is that you could have work which you can kind of put it from a continuum from projects to continuous flow. In projects, every single customer is totally different, like a lawyer, right? Every client is different, or a doctor, and so there's very little standardization you can do. Whereas here, everything is the same. You're just making the same thing over and over again. It's all standardized, right? Here you have divergence in product flow. So here it is also a variety, less variety, and you have just line flow here, lots of variety and jumbled flow up here. Okay. On the horizontal axis, you have volume, and so you can see that depending on what volume it's not total volume. You could have a job shop with higher total volume than a line. It's volume per product. So how much volume per product you need, how much variety customization you need, whether you could have jumbled flow or line flow. You can pick a point here, a point there based on your product requirements, and then it gives you where you should be on this continuum. Okay? So if you're in the yellow zone, you're going to be efficient. If you're in the blue zone, you're going to be inefficient. Okay? So, and you can see that worker paced lines are kind of close to a small batch processing with small batches, whereas machine paced lines are very close to continuous flow. Because if you speed up these lines, standardize work more, automate more, you're going to end up here, right? So they kind of blend into each other. Okay, so why would anybody be in the blue zone? It seems pretty obvious. If you have a lot of customization, you're not going to do continuous flow. And if you have just one product, you're not going to do job shops. It's very obvious. Why would any company ever end up in a blue zone, or is it kind of like so obvious that nobody's ever in the blue zone? Because if nobody's ever in the blue zone, we don't need to talk about it. It's kind of like given, right? Everybody's always in the yellow zone. Why do we need to worry or study this or evaluate companies with this tool or framework? Everybody's always in the yellow zone. So there could be other factors. If there are other factors, you might be in the blue zone, you might be fine, right? There could be a factor that takes you into the blue zone, but then you are still fine because you have adjusted for that higher cost somehow, okay? So, yeah, for example, let's say, IKEA does, high volume per product, but then, they somehow increase they have a customization option as well. So obviously the cost will go up to provide the customization option, but maybe they can charge higher or something. So it could be in the blue zone, but you have to make sure that there's something that's going to pay for the higher cost, right? So there could be other factors which take you in the blue zone, but then you're adjusting for them somehow, right? So yeah, that's a good point. There are cases where you might end up in the blue zone, but then the customer is willing to pay a higher price, or somehow you could do something better. Why would a company there's no other variable involved, why would some company end up in the blue zone over time? Right, so you might start off here, right? But let's say you start off as a startup making one product really nicely. Yeah, very good point. So you could be a startup or something where you didn't have very high volumes, so you were not here, you were up here somewhere, because your volumes were low, and then suddenly one product becomes popular, right? And you now have a lot of volume per product and few products because you maybe kill off some of the non-selling ones. So you start off from low volume, high variety, and then you move into low variety, high volume, but it's happened so fast that you haven't had the time to transition your production process yet. So you're still trying to produce using this or this high volumes just because the market picked up and you don't have time to reorganize everything, right? So that could happen. You were in the right spot, but then the market conditions changed and demand factors changed, and now you're misaligned because this demand can change faster than you could reorganize all the manufacturing. So that's an external thing. What could happen internally in the company, like company strategy or something like that, that could sometimes lead them to deviate from the yellow part? That's not going to change how they're organized. Sometimes acquisitions, a lot of times big companies will acquire small companies who are doing maybe more customization and are here. Big company acquires them and they say, okay, I'm going to take your best-selling customized products, make them standardized products. So now instead of customizing for customers, these customized products that you made earlier are not going to be standard options. I'm going to just increase my variety and then move them down here a little bit because they're going to get them, because of their marketing arm, they can get them higher volumes. They reduce the variety a little bit to get better margins, and they kind of move them along here with acquisition. Very good. A lot of times what happens is companies are somewhere here for efficiencies and they want to grow. Okay? Why do companies like to grow, even if they're profitable? This is a profitable company somewhere here, but they want to grow their sales. Why would they have pressure to grow if they're profitable? Maybe if they grow, they could reduce their cost, right? Maybe competition is moving in, so they want to grow and capture the customer base before competition captures it, right? A lot of times, if a company is not growing and their profit margins are not moving, what's going to happen? What's true of the stock price? What's the stock price graph look like? Right. If you go to zero, then your profit is going to shrink over time due to inflation. Okay? If you have zero real growth, just inflation equivalent growth, then it's going to be equal. In both cases, or in either case, what will your stock price look like? Either stay the same or become low. It's not going to grow. Right? If you're a top executive, a lot of your salary is going to come through bonuses related to the stock price improvement. So you could have a company which is fine, profitable, but they would still try to grow even if they're profitable, even if they're not making a loss, because that's how the incentives are set up. The shareholders want the stock price to grow, otherwise how are they going to retire on a nice big 401k? So they're going to say, we want the stock price to go up. You are profitable, but everybody expects you to make the same amount of money year on year, so your stock price has that priced in already. So unless you surprise us somehow by a higher revenue or higher profits, stock price is not going to grow. I bought the stock at 100, it's still at 100 after a few years. Make it go up, right? So you're going to have pressure from shareholders to grow. So companies here, they produce a few products very efficiently. They start adding new products, new product lines, new variants, new SKUs, right? Suddenly they see they have too much variety and they still have a line process, and they've kind of moved up here in the blue zone where their costs start to go up because they're changing the line too much, resetting the line too much to change one product to the other, right? Same thing can happen here. You have a lot of variety, right? But then you say, okay, my margins are too low, because you may have a competitor who may make a few of your products. Let's say you make 100 different products. You may get a competitor that makes only 5 of those products, and that competitor can be here and have lower cost and lower pricing. So you have somebody come in and start undercut your pricing because they only make a few products and you make 100 products. So you start going this way, but you don't want to give up your products. You don't want to reduce the product range you carry. Maybe marketing says, okay, we're not going to cut down on this product, it's going to cut down on our sales, blah, blah, blah. So instead of going here where you cut down on variety, you end up here, okay, where you still have the high variety, but you move towards batch or line processing, right? So often it's not that companies were not in the efficient zone. At some point, companies are in the efficient zone, but when they try to add or remove products or grow, make decisions like that, they can go out of sync. Now, obviously, we see here there's a trade-off between cost and variety, right? So this suggests that if you want to offer a lot of variety, you're going to have higher cost per unit, because if you got a job shop, your cost per unit is going to be higher than if you can make the same thing on a line. You're going to pay your workers more, high-skilled workers. You're going to have low utilization of equipment, so more equipment, things like that, right? So people want to break this trade-off. They want to have the low cost per unit here, but they want to still maintain high variety. Okay, So there've been some work towards that. One popular thing that is quite popular in some industries is what they say is we're going to take a job shop and make assembly lines in the job shop. So this is a job shop that makes 100 products. Okay, so you have this big variety, big range. They will group the products based on not customers, not color or size, but based on processing requirements. So if this product requires certain steps and these 10 products require the same steps, we'll club them into one family or group. Okay? So instead of having 100 different products, taking 100 different paths to your factory, you make 10 groups so that the 10 groups may take different paths, but each group has about the same path. Then you put all the machines on each group's paths together into one cell. So you kind of have 10 factories within one big factory. Each factory focusing on a narrow range of product. So those are called cell, and it's called cellular manufacturing, but you can see this in service operations as well. So what you do is, you take a job shop and you make 10 factories or 10 cells in the job shop, and each cell or each sub-factory operates as a line process with flow in just one direction. Okay, so let's actually look at an example. So what's the advantage of doing that? So when you have a cell which has line flow and you kind of have, each product may have different volumes, but a cell has kind of knows what their workload is going to be total, then you can have more standardized operations within a cell, which means you can go to less skilled workforce, less wages. You could try to specialize the equipment for these 10 products only in the family, which are very similar. You could have more specialized equipment, which could reduce your processing times, things like that, right? Your work in process inventory is going to go down. Whenever you move towards line, assembly line can't have a lot of inventory on the line. So whenever you go towards line, your work in process inventory goes down. As we talked the last 2 weeks, WIP goes down, your throughput time goes down, your lead times go down, right? So all those good things can happen, okay? Okay, however, there's some disadvantages. Now, if you used to have just, 5 cutting machines in your factory, and now you make 10 cells, you can't put 5 machines in 10 cells. You're going to have to buy 5 more machines because each cell needs to have their own cutting machine. Because product does not move across cells. You can't take your product, go to some other cell, say, do this step for me, then bring it back. Then you're back to a job shop, you start doing that, right? So you don't want to go back to being a job shop. So you have to have each cell, whatever equipment it needs to have its own copy of that equipment. So sometimes you can have low utilization because you have too many copies of equipment because each cell needs their own equipment. Okay. Okay, so let's look at this kind of made up simple example. Okay. Let's say there are 10 things that need to happen, and we're going to compare if we do this process with batch processing, okay, versus a cell with kind of line, with a line process. So this is the example of a line process kind of worker paste. Okay, we're going to assume that customer places orders in sizes of 50. Maybe 50 is the shipping volume. We can ship them in a truck of with 50 pieces in it, things like that. So if you had a batch process, okay, then this worker would make 50 things, put them here. Then the 50 would go to the next station. He would work on the 50, put them here, go forward, make them 50. And this may not be a line. There may be different areas of the factory, and you move that cart of 50 pieces through the factory. So at any given point in time, you would have 9 carts between workstations and 1 cart which is kind of almost ready. So on average, you'd have about 10 carts of 50 pieces each in the factory. So your work in process would be about 500 pieces. If you make a cell, you don't need these carts anymore. If the 10 workers are right next to each other, you can just pass 1 piece to the next, right? Or have a conveyor, okay? So then you go to 1 piece flow in a cell. So when you go to 1 piece flow, you only have 9 pieces or 9 pieces the workers are working on, and then the last worker is working on the 10th piece. So you'll often have WIP of 10. But because you still ship in sizes of 50, you could at maximum have 49 pieces here. The 50th piece is here waiting to be finished. When it becomes 50, it'll get shipped out. So 49 pieces done here, 50th piece here, and then you have 9 pieces of the next customer order in the system. So at most, you'll go to 59 in WIP. Usually, you'll be less than 59. So the maximum WIP you can have is 59, and it usually will be lower than that. So you can see a drastic reduction in WIP when we went from batch to cellular manufacturing. This would actually become faster, because if 3 is for batch, when you specialize equipment for these few SKUs only, then you could have fewer setups. This time doesn't include setups actually, but you could have equipment which works faster because it's specialized to these products only. Okay? So you could, if you change equipment, you would actually go down there as well. Okay? Same thing for throughput time. Because each worker does 50, then passes them on, throughput time is going to be much higher. Here each worker does one piece, passes it on, so 50 pieces pass through the system much faster. So customer order spends this much time in the system. Customer order is going to go through the system with a lot longer time because it gets moved between stages very infrequently because of the large batch size. So this is the big advantages when you take batch processing or job shop, move it to one piece flow cellular manufacturing. Your WIP goes down, throughput time goes down, lead times go down, you can deliver to customer faster. Often your processing can be more efficient as well. Even in service, we see that happen. So you can see some hospitals trying out cellular manufacturing. So within a big hospital, instead of being organized by department, they'll say, okay, all the patients which need something to happen to a joint or bones or whatever will go to this area in the hospital. That area will have their own X-ray machine, their own operating theater, their own everything. So if you have a bone issue, you just go to that area and everything happens to you in that area. You don't get moved around to different departments in the whole hospital. Then you have another cell for some other type of problem where this cell has its own X-ray machine, its own operating theater, its own everything, right? Okay. So in some cases it's been successful in healthcare, some cases it's not been successful. Where it's not been successful, the issue comes, okay, you have 10 or 5 X-ray rooms in the whole hospital. Not all of them are utilized properly. There's a lot of cost to set them up, a lot of cost to have an X-ray tech in all those rooms, right? But if you didn't have these cells, your total volume of patients may be enough to keep 2 or 3 X-ray rooms busy. But now you have 5 cells, you have 5 X-ray rooms, your volume per cell is not high enough to keep all 5 rooms busy. So your costs can tend to, per patient, go up because you have some cells which don't get as much volume to keep all the machines at a high level of utilization. Right? If you can keep all the cells, if you can draw in enough patients or customers to keep all the cells working at the pace you expect them or want them to work at, then it could be useful. Yeah, you have to make people get sick. There's actually a very interesting example of that in Canada, which is kind of world's famous. I don't know if you guys have heard of this called, I don't know how to say that, it's called Shouldes Hospital in Toronto, not too far from here. It's world's famous because for what they do, they have the lowest cost per patient and the best outcomes. So the patients get healed up and leave the hospital faster. They spend less days in the hospital, which is why their also cost is less, right? The more they spend, the more the cost. They have the least recurrence rates of that problem that they fix, right? So they have very high quality care, okay? And the reason they can be low cost and high quality and high outcome at the same time is that they only do hernias. That is the only type of thing they do. Okay? Nothing else. And if you go there, it's only the line process. You go in, every patient takes the same steps. You go in, you check in, you have, they teach you something, how you're going to recover, take you to another room. So every patient goes through the same steps like a line. So if people coming in, moving to the next stop, the next stop, the next stop, then moving out. So it's kind of like a line process in the hospital, not a job shop, which is why they could reduce the cost. But what was the thing they had to give up? To get these low costs, and what did they give up? Variety. They can only handle hernias now. Okay. So you see healthcare now being specialized because of this reason. They're kind of moving across, but they're staying along the diagonal. If they still kept the variety high, they would not end up with this low cost, right? So they understood that and they moved along the diagonal, not horizontally in that matrix. So as long as you stay on the diagonal, you're going to be fine. Okay, so for service processes, let's quickly wrap up. We're almost done. We also have a similar diagonal, which is based on how much customer contact is involved. Okay, so if customer needs to be physically present, like you're getting a haircut, you can't get it without being present. There's going to be high contact. If the customer can be absent, like university admissions, you send in your documents. You don't have to be on campus to be admitted. Then there's less contact. If what you're processing is people, that's going to be high contact because you're doing something to the person. If what you're processing is their documents or something for them, like it's going to be low contact. Okay, so what we can do, again, the personal, impersonal is about customization. If every customer wants customized service for them personally, what their needs are, you're going to be here like a lawyer, right? You can't just submit your documents because every case is different. You need to talk to the lawyer, discuss your options, things like that. Versus here, everybody needs similar type of service. Like going to passport office or something, everybody just needs a passport. There's not much differences involved. So when we do that, we get a picture like this, where we have back office. This will be like the passport office, university admissions. Front office would be like a doctor checking you up, or like getting a haircut, or getting something like that, like being in a salon. Okay. What would be example of hybrid where you have both front and back? The most kind of common example we've probably all been to. Sorry? Secretary of State? Yeah. But I just renewed my license online. I didn't go. It was this for me. I just filled up online, paid it. I got my new whatever, the license plate sticker. Some things you have to go there, right? For some cases, like if you just move into the state, you have to give in your old license, then you have to go in. Even that you could do it by mail potentially. They don't have to be here. So a lot of what they do is here. Maybe some things are here, right? What about the last two cases we've talked about? Huh? Yeah, laboratory, because they have to draw out the blood, so that's the front office part, and then they're processing back office. So the case today is hybrid in a way, right? Because you have to go there to get the blood drawn out and then do the test in the back office. Oliver's Diner, hybrid. You go sit, the waiter interacts with you, but the food is prepared in the back office, right? Benihana, you would argue, is almost kind of here, because there's almost everything in front of you. So Benihana would be here, Oliver's Diner would be here, right? Very good. Okay. Do you guys see some things which used to be here moving that way, or something that used to be there moving this way? Yeah, schools used to be this, going online, moving that way. Same for universities, used to be face-to-face, moving online, going that way. Okay. Even healthcare, you can now, I don't know, my insurance can send me a letter or something that they have them online. I can ask questions online or whatever. I didn't even read it properly. I don't know what it says, but apparently you can do something on your phone or to do online where you tell your symptoms. I don't know if you can get a prescription that way, but they do something. You can? Wow. And they just send the prescription over? Yeah. Wow. So they say, okay, you have to measure your own fever or whatever, like your own blood pressure. But basic ailments are just over the counter anyway. You don't need a prescription for something like a cold or something, right? Anyway, I haven't tried that, but I know they're moving that way, right? So why are they moving this way? What's in it for them? Reduce costs, right? Because back office you can own as kind of like an assembly line type of thing, or very efficiently. You can specialize equipment. You can do all sorts of things, right? So here you can bring efficiencies in. Here you have less things, less options, or less things you can do in front of the person there. Plus, there's often more customization if the person is there. They ask for different things, stuff like that, right? So cost advantages make you move here. Yeah. Now you just take pictures yourself and send them. Yeah. So for efficiencies, they are moving that way. Plus, customers are kind of okay with it now. I guess 20, 30 years ago, internet was not that, maybe not everybody had it, or everybody was not comfortable with it. Now people grew up with internet. Now they're comfortable doing everything online, right? Okay, so one other variable that like we didn't mention that can also determine where you are on this matrix is kind of like your strategy, right? So if you wanna, some really high-end cars, like what's that one? Corvette, I believe, or some cars, they put the name of the worker who built the car, and you can go meet the worker who builds your engine or car or something, but they're really high-end cars, right? Yeah, so some high-end cars have that, but they say, okay, we're going to have this team of dedicated workers, very highly paid, very highly skilled. They're going to build your car by hand, and they're going to put their name on it, and you can even go meet them if you want to and stuff like that, right? So if that is your exclusiveness is part of your strategy, top quality, you might do more customization and job shop. If you're a low-cost company, you want to compete on prices and have low cost, then you might do something else. So your strategy can also determine where you are, because strategy is going to determine what products you offer, and then product characteristics are going to determine where you are. So when you say product, strategy is part of your product choice that you're going to offer, right?